This is a review of the Chapter 3 quiz. Remember that you may get different problems from this because each problem is pooled, but this just kind of gives you an overview of the material from Chapter 3, and hopefully it will help clear up any issues that you're having or questions that you had. Remember, if you have questions, you can always visit office hours or email me, and we can correspond via email, or we can set up another time to meet if office hours don't work for you. So for number 1, use De Morgan's law to write an equivalent statement for the given sentence. It is false that he is in Canada and he flies to Montreal. Okay, so it is false that he is in Canada and he flies to Montreal. So that's what it would look like in symbols. So De Morgan's law, we want an equivalent statement. So remember De Morgan's law, you change the and to or, and then you distribute the negation. So it would be not P or not Q. So he is not in Canada or he does not fly to Montreal. So you can see that that is actually the very first choice. Number 2, let P and Q represent the following statements. P, the hat is red. Q, the shoe is black. Write the compound statement in words. So it's P, the hat is red. The conjunction, which is an and. So if you have these multiple choice, anytime you have this, you should know that this is an and. So if you see or, you know that that's not going to be the correct answer. It's not an if-then, so it can't be that one. So we have ands in the first, and this are the C and the D. So we're looking for those. So P is the hat is red. Well, it has to be C because D says the hat is not red. So the hat is red and the shoe is not black. So that corresponds to the correct answer. Construct a truth table for the statement. All right, so they give us A and B, and now we're going to construct the other columns. So A implies B. Remember that this is only false if you have a true false. So if you have a true true, like here, we start with a true and we end with a true, then this is true. On the second one, we start with a true, but we end with a false. If you start with a true and end with a false, that's when you're going to get a false statement. Anytime you start with a false, it's always true. Whoops, I am messing this up. Let's try again. So anytime you start with a false, you always get a true when you're doing this conditional, okay, this if-then statement. Then in number 2, we want to know not B, if and only if A implies B. So we want to kind of make a quick little chart for ourselves of not B. So that would be false, true, false, true, because it's the opposite of B, right? So if you have this biconditional, if they have the same truth value, then it's true. So we're looking at false, false, and true. Those are not the same, so that means this is going to be false. True, false, those are not the same, so this is going to be false. False, true, those are not the same, so this is going to be false. And then finally we have true and true. Those are the same truth value, so it would be true. If we had false, false, it would still be true. So if it's the same truth value, then it's true. That's for the biconditional. Okay, so let's fill in the little circles. For number 1, we have a true. 2, we have false. 3, we have false. 4, we have false. 5 is true. 6 is false. 7 is true. And 8 is true. Number 4, write the negation of the statement all dodo birds fly. So remember the negation for these when you have all or some. If you're saying all of them do something, then all you have to do is say, well, some do not. If it's all, then the negation of that is some do not. So we're looking for some dodo birds do not fly. So that would be choice D. Okay. Number 5. Construct a truth table for the following statement. All right, so be really careful with all these negations. So we have first what's inside the parentheses. We have not P or not Q. So if it is helpful to you, you can make columns for not P and not Q. So not P, we're going to have false, false, true, true. And then not Q would be false, true, false, true. So we have this or. That means if one of them is true, then the overall statement is true. The compound statement is true. So we have false, false. Neither of those are true. So this is false. The next we have false, true. Since we have one true, this is true. Third, we have true, false. Again, since we have one true, the compound statement is true. And then last, we have two trues. So again, if at least one is true, then it's true. Okay, now we want to negate that whole thing. So we're just going to go down and write the opposite of what we got in that first column. So this one, we're going to have, since this row we have false, then this is be true. True is false, and true is false. So again, this is just negating what we just found in the previous column. So number 1, false. 2, true. 3, true. 4, false. 5 is true. 6 is false. 7 is true. And 8 is false. Okay. Number 6, determine whether the argument is valid or invalid. You may compare the argument to a standard form or use a truth table. So if you like to just memorize the standard forms that they have in the book, you can do that. That's absolutely fine. I just use a truth table because I don't want to memorize more stuff than I have to. So that's what I like to do. So we're going to have X and Y. True, true, false, false. True, false, true, false. Okay, then I'm going to find the negation of each of the, well, I only need the negation of X. So I guess I'll just do the negation of X. So that will be false, false, true, true. Okay, then I need the conjunction X and Y. So X and Y, it's a conjunction. That means they both have to be true. So in the first row, they're both true. The second row, one's false. Third, one's false. And the last one, both are false. Okay. So here is premise 1. Here is premise 2. Here's premise 1 in the truth table. Here is premise 2 in the truth table. So now I want to see what happens if I combine those together as a conjunction. So premise 1 and premise 2. Okay. So that means they both have to be true. So this one's false, 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 false. So at least one is false all the way down. So it means all of these are going to be false. Okay, last step is to show that the conjunction, premise 1 and premise 2, implies the conclusion, which in this case is Y. Remember that if you're trying to do one of these if-then statements, if the first piece, this part is false, then it's always true. And if you look in the red, they're all false. So this entire column is going to be true. Since this entire column is true, this is the column of the argument. If they're all true, then that's a valid argument. So in this case, the argument is valid. All right, number 7. Determine the truth value of the statement P and not Q or R using the following conditions. All right, so we have 2 different parts. So let's just look at part A first. I'm going to write the truth value above each piece. So it says P is false, Q is false. Well, here I have not Q. So if it's Q is false, then not Q will be true. Okay, before I move forward, I want to look at this. This is P and not Q. In order for this to be true, they both have to be true, because remember, this is an and. So overall, this is false. Okay, now I'm going to look at the R. It says R is false. So I have false, false, or false. Well, they're both false. So overall, this is going to be false. Okay, let's do the next one, part B. So if P is false, Q is true. If Q is true, then not Q, the negation of Q, is going to be false. Since this is an and, they both have to be true to be true. Since they're both false, overall this is going to be false. Okay, and then it says R is true. So now I have false or true. In an or statement, or a disjunction statement, only one of them has to be true for it to be true overall. Since the R is true, this is going to be true. So part B is true. Number 8. Let P, Q, and R represent the following simple statements. P, the stove is hot. Q, the chair is broken. R, I work hard. Write the symbolic statement in words. So remember that if you have parentheses, that indicates that you're going to have a comma after that. Okay, so this is P or Q. The stove is hot or the chair is broken. So the stove is hot or the chair is broken. Then you have a comma, so it already looks like it's going to be answer choice D. But let's make sure the rest of it makes sense. Then you have a conjunction, so it'd be and, not R. I do not work hard. So D would be the correct answer. Number 9, write this statement in symbolic form. Let P and Q represent the following statements. P is the ocean is salty. Q, the waves are big. It is false that the ocean is salty or the waves are big. So it is false that starts with the negation symbol, and then you're going to have parentheses. All 4 answer choices start like that. So, except for B. B does not have parentheses, so we can cross that one out. It is false that the ocean is salty, so that's P, right? Or, remember the or is like that, the waves are big, so Q. So that's going to leave us choice D. That's actually the only one that's a disjunction that we haven't crossed out yet. So the answer is D. Number 10. Construct a truth table for the following statement. Okay, so we have not P or not Q. So not P is just going to be the opposite of P. So false, false, true, true. Not Q is the opposite of Q. So false, true, false, true. Not P or not Q. Again, this is the key. This is an or. It's a disjunction. That means only one of these have to be true in order for this compound statement to be true. So if I look on the first row, I have two falses, because remember I'm only looking at this and this. Two falses, so that's going to still be false. On the second row, the blue is true, so that makes the compound statement true. On the third row, the red is true, so that's going to make the compound statement true. And the final row, they're both true, so the compound statement will be true. All right, so let's fill in all the circles. 1 is false, 2 is false, 3 is false, 4 is false, 5 is true, 6 is true, 7 is true, 8 is false, and 9 is true. 10, 11, and 12 are all true. And that would be the truth table. Okay, number 11, we have another truth table. This one's larger, but same idea. So don't freak out just because it's a big truth table. So construct a truth table for the statement. All right, so we have not R implies not Q. So remember for this one, it's always true unless the first thing is true and the second thing is false. So we are going to be looking at the not R and the not Q. So the not R. First, this is what I do. Anything where the first thing is false, I automatically know that all of those are going to be true. You don't even have to think about it. If the first one is false, it's automatically true for this conditional statement. The only thing you have to worry about is if the first one is true and the second one is false. So if you look here, the first one is true, but the second one is false. That means this is going to be false. On the next one, they're both true, so this is true. The next one, we've got this false, so since it's true, false, this is false. And on the very bottom, they're both true, so this is true. Okay, so now we have P implies R. So this is kind of the same idea. We're going to go over to the P, and anything that's false for P, we're going to go ahead and write a true, because we know that if the first thing is false, the compound statement, this conditional statement, is true. Now we want to look to see if the first thing is true, is the second thing true or false? So let's do that. We have P implies R, so make sure you're looking at the R column. So this is true, false, true, false. Okay, so since it's true, true, this is true. True, false, that would be false. True, true is true, and true, false is false. Okay, so now this is the blue if and only if the red. Why did I put a T there? Let's see, this is the blue. This is the blue column if and only if the red column. Okay, so that's what we're looking at for this biconditional statement. The blue truth values and the red truth values. And we want to see if they match. Remember, for the biconditional statements, if they match, then it's true. So on the first row, they are both true. They match, so the answer is true. Okay. On the second row, they're both false. That matches, so it's true. The third row, they're both true. That matches, true. Fourth row, one is true and one is false. So since they do not match, that's a false. Fifth row, they're both true. They match, so true. Sixth row, one is false and one is true. They do not match, so it's false. Seventh row, they're both true. They match, so true. And the last row, they match. They're both true, so true. Okay, so if we're going to fill in our blanks here, our circles for the corresponding answers. We have 1 is true, 2 is true, and 3 is true. Okay, then we have 4 is false, 5 is false, and 6 is true. We have 7 is true, 8 is true, and 9 is true. Okay, then we have 10 is true, 11 is false, so that makes 12 false. Then we have 13 is true, 14 is true, 15 is true. 16 is false, whoops. 17 is true, so 18 is false. 19 is true, 20 is true, and 21 is true. And then finally we have 22, 23, and 24 are all also true. Okay, so even though that one was long, it was a bigger table, it still wasn't that difficult. Just remember to take it piece by piece and really think about what you're asking. Okay, the final one for this quiz review. Select the converse, inverse, and contrapositive for the following statements. So you need to make sure you remember what these are. So if P implies Q is your original statement, the converse is always, you just switch the order. So now Q will imply P. That's the converse. The inverse means that you keep the same original order, but you negate each of them. And then the contrapositive, this means you change the order and you negate them both. So Q is going to go first, not Q implies not P. So you need to have that memorized so that you can use it for the words. So on the first one, the words should just be switched. The phrases should be switched. So here you can see that P is goblins come out to play. Remember, the do not is the negation. And then it is Halloween is Q. So we want it to be switched. So we want to say if it is Halloween, so not this one because it has a not. We want Halloween to be first. If it is Halloween, then the goblins do not come out to play. So we didn't change the nots. We just switched the order. All right, the next part is finding the inverse. So we want to keep the order the same, but we want to negate each part. So originally we have do not for the red part. So now we want to say if goblins come out to play. So if goblins come out to play, well, it looks like it's only the last one. Then it is not Halloween. So that would make sense, the last one. Okay, contrapositive. We want to negate both pieces and switch the order. So we want to start with if it is not Halloween. So it's not that one. So really, if you just know the order, you can really pick out the answer pretty easily because the other ones are not going to make sense. So if it is not Halloween, then the goblins come out to play. So that would be the correct answer for that one. So really quickly, just to give you kind of an overview of the information that you should have when you're studying, remember that this is a disjunction. It means or. Okay. And this is true when one is true. So if one of the statements are true, then the compound statement is true. This is a conjunction. It's an and this is true when both statements are true. So both statements in the conjunction must be true for this to be true, the compound statement to be true. Then we learned about the conditional statement This is only false when you have a true implies a false. Okay, so if the first thing is true and that's implying a false thing, then it's false. It's always true in any other circumstance. Then we have the biconditional statement. This is true when the truth values match. So that means if you have a false, false, that's true. If you have a true, true, that's true. But if they're not the same truth value, then it's false. Okay, so then some more information that you should have that we use quite often. P implies Q is equivalent to not P or Q. So you should know that. They use that a lot. We already went over the converse, inverse, and contrapositive, so you should know that. And then the last thing is De Morgan's law. Okay, so De Morgan's law is if you're taking the negation of P or Q in parentheses, that's equivalent to not P and not Q. Okay. So anytime, and this is also true, so I can put it in blue just to show you it's the same type of information. You could do not P and Q would be equivalent to not P or not Q. So you negate each piece inside and then you change the value of the conjunction or disjunction. Okay. So I hope this helps you in reviewing Chapter 3 material. Again, if you have any questions, please just let me know.